Bismillahirrahmanirrahim. I am Dr. Abdul Sabta from Abdul Omens Medical College. I am taking a lecture class instead of practical. This lecture is the continuation of previous lecture. Resistance. What is resistance? Resistance is the impediment to flow of blood in the vessel. That is, when blood flows through the vessel, there is some friction between blood and the internal layer of the blood vessel, that is endothelial layer. It cannot be measured directly, it can be measured indirectly. How you can measure a resistance? R is directly proportional to delta P and inversely proportional to flow. Now, there is two types of resistance. One is systemic resistance, another is pulmonary resistance. How you can measure systemic resistance? Suppose in left ventricular pressure, mean pressure is 100 millimeter mercury and right atrial pressure is 0 millimeter mercury. How much the pressure difference? It is 100 millimeter of mercury. Now come to the flow. We know the cardiac output is 5 liter per minute, but if you can increase the cardiac output 6 liter or 6000 milliliter per minute, then every second 100 ml of blood will flow. That is, blood flow is 100 ml per second. Now, if you, how much the pressure difference? 100. How much the blood flow is? 100 milliliter per second. How much the resistance? 1. That is called peripheral resistance unit. Peripheral resistance unit. It is over. If strong sympathetic stimulation, the resistance unit increase to 4-fold. When there is a strong parasympathetic stimulation, the resistance unit decrease to 2.2. That is, when the resistance is 4-fold increase, it means the severe constriction of the blood vessels. When it is a fall, 0.2 means the blood vessel will dilate. Now come to the pulmonary resistance. Pulmonary resistance. How you can measure pulmonary resistance? Mean pulmonary arterial pressure is 16 millimeter of mercury and left atrial pressure is plus 2 millimeter of mercury, and 16 millimeter minus 2 millimeter, how much the pressure difference? 14 millimeter of mercury. Now again, if you put this figure here, 14 divided by 100, it means about 7. That is, the pulmonary resistance is 1/7 of systemic resistance. Systemic resistance. Now you can find another difference between the pulmonary circulation and the systemic circulation. The pulmonary circulation resistance is high, that is, therefore it is a high pressure resistance bed, and pulmonary circulation is low pressure resistance bed. Another difference of pulmonary circulation and systemic circulation, it is the greater circulation in systemic circulation from left ventricle up to the right atrium. Pulmonary circulation is the lesser circulation. It is from right ventricle to the left atrium. This is the. Now, how you can total peripheral resistance. Total peripheral resistance. Total peripheral resistance, if you draw a blood vessel, this is the series of blood vessels. Here R1, here R2. Then this is the summation of R1 and R2 in the total peripheral resistance. Similar, the resistance is also offered by parallel blood vessels. Suppose this is the blood vessels. This is the R1, R2, R3, R4. That is all the summation of R1, R2, R3, R4 is the total peripheral resistance summation. Now, in 1840, French physician is Poggius. He described the blood flow occurs through a cylindrical vessels. It is not a straight line. It is not a pass through a wire, but it pass through a cylindrical vessels. Now he changed this to Poggius law. That is, flow is directly proportional to pi delta p and fourth power of the radius, and inversely proportional to eta L, length of the tube. Now F means flow, pi is cylindrical tubes, delta P is pressure difference, and R is the radius of the vessels, N is the viscosity of blood, L is the length of the blood vessels. Now, in 1840, he showed this Poggius law, or Poggius, he showed that resistance is directly proportional to viscosity of blood and length of the tubes. When the blood viscosity is increased, there is an increased resistance. Blood viscosity is increased in some condition. If the hematocrit is increased, what is hematocrit? Hematocrit is the PCB. Another name of hematocrit is PCB. PCB or hematocrit. PCB is the percentage of cell to whole blood. When the hematocrit is increased, that is the increased resistance. And viscosity of blood is 3 times as great as water, and viscosity of plasma is 1.5 times as more than water. This, in any condition, the viscosity is increased, resistance will increase, and blood pressure will also increase. Usually in high altitude, there is a hypoxia. Hypoxia stimulates the excess production of RBC. That time viscosity increase about 60 to 70%. Usually the PCB is 38 to 42%. It does means total peripheral resistance. What is total peripheral resistance? Suppose the resistance usually offered in series of blood vessels, another parallel blood vessels. Series of blood vessels is R1, R2. This is the series of blood vessels. Then again is parallel blood vessel. This is the parallel blood vessel. R1, R2, R3, R4. This is the R1 plus R2 plus R3 plus R4. This is the total peripheral resistance. Now, I think I'll shift to the another. Now, Usually the blood flow and electric flow is not same. Blood flow usually through a cylindrical tube. Then 1840, Porgius, he showed and he described a equation, a law, that is Porgius law is the flow is directly proportional to pi and delta p and 4 parts of the radius of the blood vessel, and it is also inversely proportional to eta and length of the tube. Here F is the flow, pi is the cylindrical tubes, delta p is the pressure difference, r is the radius of the vessels, then 8 is the Hessman factor, eta the viscosity of blood, L length of the blood vessel. Now if you compare the Ohm's law and to this Porgius law, that is flow is directly proportional to pi and pressure difference and 4 parts of the radius of the vessels, and inversely proportional to the viscosity of blood and length of the blood vessels. Length of the blood vessel. That is, it was first introduced by Porgius because it does indicate that resistance is directly proportional to viscosity of blood and length of the tubes. Now, when the viscosity of blood is increased, and if you compare the viscosity of blood with water, if the viscosity of water is 1, then blood viscosity is 3 times as great as water, and plasma is 1.5 times than water. When the viscosity of blood is increased, suppose in high altitude, the PCB or hematocrit is increased about 70%. That time the viscosity of blood is 10 times more than water. Viscosity of blood, it depends on quantity of RBC in the blood. That is, another name is PCB or hematocrit. What is hematocrit? Hematocrit is the percentage of cell to whole blood. Usually, normally, varies from 42% to 45%. It does means that when 42%, 100 ml of blood, 42 ml is RBC and remaining 58 ml of plasma. Usually the viscosity of blood is 3 times as great as water, and plasma is 1.5 times as great of water. The blood viscosity is 3 times than water. Water viscosity is 1. In some condition, if, as for example, high altitude, the viscosity may increase up to 60 to 70%. That time resistance will be increased. Similar, when the PCB is decreased in anemia, that time the blood flow, there is some sound occurs that is called murmur. You may get in murmur in anemia. That time the blood flow is usually, that is, blood flow is inversely related to resistance. When resistance is decreased, blood flow will increase. If resistance is increased, blood flow will decrease. I think this is enough. This slide, you have just give attention to this slide. It will show you the interrelation of lectures that has been given by Salma ma'am, Sibila ma'am and me. Already you have known that what is cardiac output, how cardiac output has been correlated. This is end diastolic volume and systolic volume. This is the stroke volume. Then stroke volume is the times the heart rate is the cardiac output. What is stroke volume? Stroke volume is the end diastolic volume minus end systolic volume, the stroke volume. What is cardiac output? That is cardiac output is the heart rate and stroke volume. Now it comes to the Sibila ma'am. Sibila ma'am, she already given you lecture about the blood pressure. Blood pressure is the product of cardiac output times the total peripheral resistance. Now come to the how tissue flow is be controlled. Tissue flow is controlled is the control. F is directly proportional to the pressure difference and inversely proportional to resistance. Our aim of three lecture is to ensure that tissue blood flow. Tissue blood flow, how the tissue blood flow is controlled. Tissue blood flow is controlled by total peripheral resistance. And total peripheral resistance, maximum total peripheral resistance is offered by arterioles, meta-arterioles and pre-capillary sphincter. And that is tissue vasomotor tone, and it is controlled by sympathetic nervous system. When strong sympathetic stimulation, before I mentioned it increase fourfold. When sympathetic inhibition, it goes to the 0.2. When increased sympathetic tone, the total peripheral resistance is increased and blood pressure will increase. Now come to the another slide. This is the another slide. I am showing the slide that is blood flow to different organ and tissue under basal condition. It is very important and you have to remember this always. That is tissue or organ, percentage of cardiac output, milliliter per minute, how much the blood is flow per minute. And this is the milliliter per 100 gram of tissue, that is brain. 14% of cardiac output, the brain will get 14% of cardiac output. Total blood is 700 milliliter and per 100 gram of tissue is 50 ml per 100 gram of tissue. Again heart will get 4% of cardiac output. That is total is 200 ml per minute and it is the 70 ml per 100 gram of tissue. Now come to the kidney. It is that the blood flow to kidney is 22%. It is about 1100 milliliter per minute and it is about 360 per 100 gram of tissue, 360 ml per 100 gram of tissue. Now come to the another, this is the thyroid gland. Total cardiac output is 1% and total blood flow is, thyroid gland is 50 ml. It is 160 ml per 100 gram of tissue of thyroid gland. Again, adrenal gland, the blood flow is 0.5%. It is 25 ml, total blood flow is 25 ml. It is about 300 ml per 100 gram of tissue. If you compare which organ gets more blood supply, first is the kidney. On the basis of 100 gram of tissue, it is 360 ml per 100 gram of tissue. Next to kidney is the adrenal gland. It is 300 ml per 100 gram of tissue. Third one is thyroid gland. It is about 160 ml per 100 gram of tissue. Before going to conclusion, I want to say when flow will cease, that is called critical closing pressure. Critical closing pressure, the pressure at which the flow will cease, it is about 20 or below 20 millimeter of mercury. When blood pressure is 20 or below 20 millimeter of mercury, the flow will cease. That is called critical closing pressure. Today I have concluded my lecture. Thank you. Stay at home.